Hello everybody, this is Solartiger with another video. Today is Tuesday the 28th of April and this video is going to be about batteries. Okay, now as you know I use a lot of rechargeable batteries in my various devices, mainly in my LED lights and in some other devices that I have. I have a selection of batteries here. I have some AAA batteries, some AA batteries, some C-size batteries, and a 9-volt battery. Now, I'm going to concentrate mostly on the AAA and the AA batteries. Now, as you can see here in the selection on the left, I have a selection of AAA rechargeable batteries. Now, these batteries are all 1.2 volt nickel metal hydride batteries. I will make a point here that although we call these batteries, these are more correctly battery cells. These are individual cells. They have a voltage of 1.2 volts, but most people incorrectly call these batteries. I'm just making the point here that they are actually individual 1.2 volt cells, but from here on I will refer to them as batteries. So these are individual cells. These are all individual cells apart from this 9 volt battery here. This is actually a battery, since it contains several 1.2 volt cells connected in series to produce the terminal voltage of 8.4 volts. So this is correctly described as a battery. There are several cells wired in series inside to make the 8.4 volts. So I shall put this one back. So all the others are actually correctly called cells. So if I concentrate on these AAA batteries, they have different capacities. The capacity of a battery to hold electrical energy is measured in units called ampere hours, or for the smaller batteries, milliamp hours. Now, in this group here, I have arranged them in order of capacity, from the lowest on the left to the highest on the right. Now, as these batteries are all physically the same size, the ones with the higher milliamp hour rating have a greater energy density, which means that when you put them in your devices, the device will work for a longer period. So on the left here we have ratings from 550 milliamp hours through 500, 750, 800, 850, 900, and the one on the far right has a capacity of 1800 milliamp hours. So that one would last the longest in your device. So I would say that it has the highest energy density. So the amount of the energy density of the battery, or its capacity, varies with quality and price and the manufacturer. Generally, the higher quality batteries have a higher milliamp hour rating than the cheaper batteries. They are cheaper for a reason. They contain less active material, and that is why they store less energy. So they may be cheap, but they are not good value in the long term. You're better off spending your money to get a better quality battery that has more more chemicals inside that will store greater amounts of energy. So if I go on to the AA batteries, the same thing here. We have the lowest milliamp hour rating on the left, going through to the highest on the right. If I pick up one of the batteries with the lowest rating, this one here, it has a capacity of 400 milliamp hours, which is not very much for a AA battery. This battery is typically found in cheap solar garden lights. They are only a pound or two from shops like Poundland and discount shops, where the whole light might cost just £1. So the whole product is made to a cheap price, so they use cheap batteries. Now this battery is very light, there's virtually no weight to it, so it's not very good quality. It has very little active ingredients in it, so it stores very little energy. The battery next to it is only marginally better. It has a capacity of 600 milliamp hours, so not much better than the last one. And then we have ratings of 1300 milliamp hours, 1700 milliamp hours, 2000 milliamp hours, 2400 milliamp hours, 2500 milliamp hours, and the one on the far right is 2600 milliamp hours. Now, if I compare the weight of the 400 milliamp hour battery to the 2600 milliamp hour battery, this battery is much heavier than the 400 milliamp hour battery, so it is better quality. It has more active ingredients in it, so it can store more energy. So these batteries were marketed for use in digital cameras, which are well known for eating through batteries. So you need a battery with a high milliamp hour rating to make sure your camera would operate for longer. So this is a longer lasting battery between charges. So generally the batteries with a higher milliamp hour rating are heavier, they're usually more expensive, and they're usually of well-known brands. So well-known brands include Duracell and Energizer and other well-known brands. So you can tell the quality of a battery by its weight. The good quality batteries are heavier, and the cheaper quality low capacity batteries are much lighter and usually are of brands that you've never heard of or no brand at all. So that's that. At the back here I have some C-size batteries. These ones are pretty heavy, and these have a capacity of 5000 milliamp hours. Now 5000 milliamp hours is exactly the same as 5 amp hours. They are the same. So these are a high capacity C-size battery. You can get ratings anywhere from about 2 amp hours, 2000 milliamp hours, up to these 5 amp hour ones. These 5 amp hour ones are more expensive. The typical values are 2000 milliamp hours, 3000 are common. You have to look harder to find ones of 4,000 and 5,000 milliamp hours, but they are well worth looking for, as these type of batteries normally go in torch lights and things like portable radios and CD boom boxes and devices like that, which are heavy on batteries. So investing in a high capacity battery is good because your device will go for much longer. So that's that. Now when it comes to charging your batteries, if I get rid of this one because it doesn't, I'll get rid of this one because it doesn't stand up because it has had wires soldered to it before. Now if I take a battery, I shall take a battery. Now batteries are labelled. If I put it down here a bit, you might be able to see. You'll focus in a second. Focus. There we go. Right. The battery is labelled with its voltage, 1.2 volts, and the capacity, in this case, 2,400 milliamp hours. So, for example, it could supply a current of 240 milliamps for 10 hours. So that's how the rating is calculated. Now, as you can see here, I'll just steady my hand a minute. Now it says standard charge rate 16 hours at 240 milliamps. So that is the recommended charging rate. So that would be overnight in most standard type battery chargers. Now you will probably find that obviously these charging values differ from one battery to another. If I take another one, I'll take the C-size one, and it says, if I can get it to stay still. Right, so this is the charging information for an AA cell battery, and here we have a C-size cell, and if I try to do this, now you can see here that it says it has a maximum capacity of 5,000 milliamp hours, and the standard charging rate is 500 milliamps. Doesn't give a time on this battery, but probably 16 hours would be about typical overnight charge. Now these batteries that I have, all of these ones, I'll just focus, all of these ones, all of these batteries are nickel metal hydride. That is that refers to the chemical composition of the battery. These are the most common type of rechargeable battery, and they can be recycled at the end of their working life. So these are nickel metal hydride. An older type of battery that you might find are called NiCad, but they are being phased out because they contain toxic chemicals. The NiCad stands for nickel cadmium, and it's the cadmium that is a toxic material, so they're being phased out. They also suffer from something called the memory effect. That is, if you don't discharge them completely when you charge them, they won't charge up fully again. So that's another reason why they were phased out. The nickel metal hydride batteries can be discharged all the way down and will charge up again without any kind of memory effect. So that's one thing. Okay, right. So when you come to charge your batteries, you'll probably put them in one of these AC chargers, or I have a DC charger. Now, this one is I've turned it upside down, so this is actually the bottom, because there are some details on the bottom of this charger. Right, there are some electrical ratings here. Now this charger can charge the AA, treble A, C and D cells, along with the 9-volt cells as well, and it gives you the output current of the charger. So for the 1.2 volt cells, it can put out 270 milliamps, and that's for each charging position, and it puts out 13 milliamps for each of the 9-volt positions. So that's what the charger puts out. Now this charger has a chart on the bottom of the charger. Not all of them do, but this one does, and it gives you a table and a guide for the charging time of the batteries, depending on the milliamp hour rating. Now this charger does NiCads as well as the nickel metal hydrides, but since I don't have the NiCad cells anymore, and I only have the nickel metal hydride ones, you would basically ignore this column of the chart and you look at the nickel metal hydride side. So for example, if you have an 800 milliamp hour AAA battery, and the recommended charge time is just 4 hours. For an example, AA battery might have 2100 milliamp hours. The recommended charge time for that is 10 hours. And for a typical C size cell, 3.5 amp hours one would take 18 hours, and a typical D cell that had 4000 milliamp hours would take 21 hours. Now that is just a guide, so you look at this chart and the capacity that's rated on your battery, and you'll have a guide of how long to charge it for. That's also dependent on how flat your battery is. If your battery is not that flat, it will charge up quicker, and if your battery is very flat, it may take longer. So this is a universal charger. It's a mains model, and it's just a typical charger. If I turn it over, I'll try not to make too much noise because it's late at night now. Okay, so this is the top of the charger. There's the positions for the 1.2 volt batteries. There's 1, 2, 3, 4 positions, and for the 9 volt batteries, 1 and 2. If you put your battery in this position here, it also has a battery testing function. You gauge the charge of your battery by how bright that the indicator light shines. It's just a guide. This charger has a timer. You put the batteries in and you set the timer according to the chart that was on the base of the charger. So you got 4 hours, 10 hours, 18 hours and 21 hours. So this charger would shut off automatically after the length of time has elapsed. Not all chargers have a timer. Some, like my DC charger, has a full charge automatic detection, i.e. it terminates the charge as soon as the battery is charged. So, and the indicator light changes colour from red to green. So that is good. So this is how that works. So this was just a video about batteries, some information on batteries. Now the things I've said here equally apply to the larger batteries that we use in our solar power system. They have capacities that are rated in amp hours, and the things about quality apply the same. So, but this was just mainly about the single cells that we put in our everyday devices like lights and radios and things like that. So I hope you found this video interesting and useful. So this is Solartiger saying thank you, and thank you for watching, and until next time, goodbye. Thank you.